Okay, this is 34. All right, so it says match lines, the blue line, red line, and green line with the slopes right here. So one slope is negative 1.7. So we know that has to be the red one. It's the only one with the negative slope. So L1 is, actually L1 is the blue one. So L1 is the blue one that's got a constant slope. So that's going to be m equals 0. Or you can just put in A. The slope of L3, which is the green one, is a positive slope. So that's got to be 0.3. So we'll put in B for that one. The slope of L2 then, which is the red one, it has the negative slope. So that's going to be A. I'm sorry. L2 is the red one, so that's going to be A. So number 1, slope of L1 is the blue one, and that's 0, that's C. All right, so the next one wants an equation of a line that goes through these 2 points and can be written in general form. So what I'm going to do is I'm going to do this in point-slope form. There's different ways to do this, but you could put it in slope-intercept form if you wanted to and rearrange it from there as well. But I'm going to do this one. So then I'd have my numbers are here, so I'd have y minus, I'll do this point as my x1, y1. My slope times x minus 8 as well. So I need to find my slope, so that's y2 minus y1 over x2 minus x1, which gives me negative 1 over negative 3, which is 1/3 for me. All right, now I would distribute this and rearrange. So I have y minus 8 equals 1/3 x. Actually, what I'm going to do is multiply through by 3 now to get rid of the fractions. If I multiply this by 3, this turns into negative 24. This goes away. And I can drop these parentheses then. Now I'm going to rearrange, so I have negative x plus 3y minus negative 24, and if I add 8 to both sides, that gives me negative 16 equals 0. So I should be able to plug in negative 1 for A, B should be 3, and C should be negative 16. All right, the next problem is another line problem, similar to what we've done a lot in the past, like in Algebra 2, only this equation looks a little different. Usually we write it like this, y minus y1 equals m times x minus x1. We call this point-slope form. It's the same equation, only they've called it y sub 0 instead of y sub 1, and they've moved it over to the right side. But nonetheless, we can use this. I'll just use it real quick. Y minus y1 would be minus negative 7 equals the slope, which we're going to steal is 6 because it's parallel. And it's x minus x1, which is negative 5. So that'd be y plus, so I'll move the 7 over. This is going to be plus 7, but I'm going to move it over to the left, so it's negative 7 plus 6 times x plus 5. And that's my answer that they want right here in this form. Okay, the next one says consider a line with an x-intercept of 2 and a y-intercept of negative 2. It can be written in slope-intercept form. All right, so the easiest way is probably to recognize that this is the y-intercept, which is negative 2, so that goes right here, right? Because y equals mx plus b. This is the y-intercept, and then this is the slope right here, m. The slope in this case goes up 2 over 2, so that's 2 over 2, rise over run, which is just 1. So that's probably the easiest way. There's other ways to do it. I mean, you could, obviously this is the point 2, 0. And this is the point 0, negative 2. So you had 2 points, so you can calculate slope with a slope formula, and then use one of the points in point-slope form, rearrange it to get it into this. There's a bunch of different ways to do it. Okay, my equation, this line right here, the slope of this is 0. And so when you do y equals mx plus b, I just have y equals the number, and b in this case is negative 4. So I just have y equals negative 4 because the slope is 0. Okay, a bunch of different ways to do the next one as well. It wants it eventually in point-slope form. I'm going to do the slope first, negative 2 minus 7 over 7 minus negative 3, which gives me negative 9 over 10. I'm going to do then y minus y1 equals m times x minus x1. So that'd be y minus 7 equals negative 9 over 10 times x minus negative 3. And I'm just going to rearrange it to get it in this form. So the negatives go positive. I'm going to distribute. So it's negative 9x over 10 plus negative 27 over 10. And then I'm going to add 7 to both sides. Move this over and add it to this side. So I'll make it over 10, so I'll make it 70 over 10. And which case, in this case, it's 43 over 10. 33 over 10, sorry. And then 9x over 10. So my slope is negative 9 over 10, and my y-intercept is 33 over 10. Next problem wants you to do slopes. You do y2 minus y1 divided by x2 minus x1 and set that equal to negative 5/8 is what it is, and then solve this. So this would be negative 8 in the bottom. You can multiply both sides by negative 8 to get rid of that, in which case these cancel. You know, put 5 on the right side, and then add 3 to both sides, so y equals 8. Next problem wants to use factoring to solve this, so I'm going to move this over to the other side, and I'm going to try to then factor it and do what they say, because keep in mind that I want to show work the proper way on a test. So this would be 2x, this would be 2x, this would be negative 1, and positive. I'm sorry, when I move this over, this should have been positive 1. So it's a perfect square trinomial, and I can solve by factoring, and then I want to enter in x equals 1/2. Next one says to solve by factoring, complete the square root of the quadratic formula. So I'm going to try to factor because that's usually the easiest, right? Just try to guess and check. Are there two numbers that multiply to negative 30 and that'd be negative 1? That'd be negative 6 and positive 5. So x equals separated by a comma, it looks like, so 6 and negative 5. Next equation is tough. It wants us to solve by completing the square. Now keep in mind, if I were to give you this problem on a test and I tell you to do completing the square, when I look at your work, I'm going to make sure that I see that right there, completing the square work. So let's do that. It's not the easiest way to solve this problem, but we're going to have to make it work. I would first divide through by 4. And the reason why is because when you complete the square, you want a to be 1. Then what you do is you add b over 2 squared to both sides. So I'm going to add negative 3/4 over 2 squared to both sides. Instead of dividing by 2, I'm going to multiply by 1/2. So I'm going to make it negative 3 over 8. And I'm going to do that squared to both sides. Now to the right side, I'll make that 9 over 64. And then when I go to factor this, then it's just x minus 3/8 squared right here. So you take the square root of this, put it here, take this and put it there. That's how you complete the square. And this would be 9 over 64. And now I can take the square root of both sides, which gives me x minus 3/8 equals plus or minus 3/8. And so when I add 3/8 to both sides, I get x equals 3/8 plus 3/8 would be 6/8. So that's one of the answers, which reduces to 3/4. And then the other answer is 3/8 minus 3/8, which is 0. So 3/4 and 0, and they wanted the smaller one first. All right, now they're completing the square problem. I'm going to move this 11 over. So I have y minus 11 equals negative x squared minus 18x. I'm going to get rid of the negative right here because I want that to be 1 again. So I'm going to divide through by negative. And then I'm going to complete the square on this side. So I'm going to add b over 2 squared to both sides. So 18 over 2 is 9 squared to both sides. In this case, it's 81. So I have negative y plus 92 equals x plus 9 squared. And I'm almost done. I'm going to move the 92 back over, so subtract 92 from both sides. And then I'm going to also get rid of the negative again. So move the negative back over here by multiplying both sides by a negative. So there's my answer. My a is negative 1, and my h is negative 9, and my k is 92. Next problem wants me to use the quadratic formula to solve this, which if you remember is b squared plus or minus square root of b squared minus 4ac all over 2a. So opposite of negative, b is negative 2. Double negatives would cancel and be positive 2. b is negative 2, but negative 2 squared gives me 4. 4 times a times c and 2 times a. Okay? Double negatives cancel. 4 times 4 is 16 times 2 is 32. Plus 4 is 36. Square root of 36 is 6. In the bottom I have 4. So I have 2 plus 6, which is 8 over 4, which is 2. And I have 2 minus 6, which is negative 4 over 4, which is negative 1. So there's the two answers. Okay, this is a really long problem. Sorry, but let's just do one step at a time. So the first one, kind of a trick. We're going to call x equal w squared, and then we'll call the square root of x equal to w. Right? So when I square w squared, I get x. You can see this pattern. The reason I'm going to do that is because then I can make this quadratic. So x is w squared minus 5w plus 2 equals 0. Now I can solve this hopefully by factoring. We'll see. 2w and w plus 2, 5 and 1. Let's try. Maybe minus 1. Nope, that doesn't work. I don't know why I put a 5 there. That definitely doesn't work. I actually tried a couple different things, and finally, it wasn't that hard. This was the right one. 2w. You want a 2 and a 1, obviously, to get a 2. And then this works to get the middle term of negative 5w. So once you solve this, then you have 2w minus 1 equals 0. So add 1 to both sides and divide by 2. That's w equals 1/2 is one of the solutions. The other solution is w equals 2 from this factor. Now keep in mind that w is really square root of x, so put in the square root of x right here. And square both sides. So you get x equals 1/4 and x equals 4. So up here, the smaller is 1/4 and the larger is 4. Alright, so next one, similar, where you're factoring still. It's the same factorization, only different powers. So we had 2, now this time it's going to be x squared, and this is going to be x squared. And then we want minus 2, minus 1. So that's the same factorization, only this time we have a second power here instead of first power. But we can still solve these because this still equals 0. Set this factor equal to 0. 2x squared minus 1 equals 0. Add 1 to both sides. Divide by 2 and square root both sides. And you get x equals plus or minus 1/2. And this has two positive real solutions. So let's use the positive 1/2. And then the other solution comes from over here. X squared minus 2. So x squared minus 2, move the 2 over. Square root, you get x equals plus or minus square root of 2, so we'll use the positive square root of 2 as the larger one. Alright, the next one, it doesn't look like a quadratic, but we'll get it to look like one. Actually, whenever there's equal signs in a fraction, we can clear fractions, right? So we're going to multiply through by x minus 1, x plus 1 to everything, because that's the least common denominator. I have to do it to that as well. So when you do this, this x minus 1 is going to cancel, and I get x plus 1 times 1. So I'll just leave it as x plus 1. Minus, this x plus 1 is going to cancel, so I'll end up with x times x minus 1. And then I still have minus 2 times the whole thing. I didn't write it, but x plus 1, x minus 1. And that still equals 0. So now it's a quadratic. Obviously I need to get it in standard form and simplify, but I can do that. X plus 1 minus x squared plus x. Actually, I'll FOIL this out first and then distribute it. So plus negative 2 times x squared minus 1. Then distribute, and that gives me negative 2x squared plus 2. So I'll write that here. Negative 2x squared plus 2 equals 0. Okay, so now I'll add this and this to get negative 3x squared. Those cancel. I'll add this and this to get plus 2x, and this to get plus 3. And I'll try to factor this if I can. We'll see. 3x squared times x, 3x times x rather, plus 3 plus 1. I'm actually going to back up and multiply through by a negative, so that makes this negative and this negative, and try factoring again. 3x, x, In the amount of time on this video, this didn't work, but you can use quadratic formula.